Types of navigation we're using every day: visual, radio, and satellite navigation, and where it pertains to Tradewind's operations. I'll try to make a couple points. So we'll start with visual pilotage and dead reckoning. I know it's easy to stare at the MFD or the GPS screen a lot, but it's still useful to look outside and know where a lot of the VFR waypoints are, especially around New York, Alpine Tower, things like that. Of course, we're going to be using pilotage. But what I try to do a lot of times is, instead of just using the GPS to figure out where airspace boundaries are, a lot of times I'll note the DME if there's a VOR or prominent landmark that marks the boundary as well, in case I don't have the map up or for some other reason I'm not able to look at the MFD. Also, points of interest around airports. If they tell you, enter a 3-mile final, well, where on the ground is a 3-mile final? The GPS will tell you when you're 3 miles out, but it's a good idea to be able to point to something and know exactly where you're going, instead of just trying to adjust based on the DME or the miles on the GPS. So yeah, VFR corridor, as I mentioned, and it's okay to take your eyes off the MFD. And as was mentioned in a previous presentation, you're responsible for seeing a void during visual operations under IFR or VFR. And we have the New York skyline and the New York SFRA. There are tons of landmarks on those charts that are useful to us when we're operating in that area. Dead reckoning, we don't plot our courses anymore, but when you go GPS direct, the GPS is essentially giving you dead reckoning from your position to your destination. It gives you a course, tells you your ground track, and you can compare those things to see what the wind is if you don't have a wind readout. But it's still a good idea to understand the concepts behind that, the things that you learned in your private pilot training. The different airspeeds: true airspeed, calibrated airspeed, ground speed, indicated airspeed. Some of those things are obvious, but I don't know, every once in a while you run into somebody that might have the wrong idea of what airspeeds they're looking at. Compass deviation, magnetic deviation, what's the difference? That's a really basic thing, but it's easy to forget when you don't think about it for a long time. Wind correction, if you're not on autopilot in nav mode, what's a good rule of thumb to figure out what your heading should be to fly a certain course? So if you don't have a rule of thumb, it's a good idea to think of one or come up with one that you know well, that works for you. Compass errors, it could happen. We could have a total electrical failure, and we might have to steer off of our compass. So it's a good idea to remember some of the compass errors: ands and unos. Accelerate north, decelerate south, undershoot north, overshoot south when you're turning, and heading versus course. These are our basic private pilot things that we've all learned in the past that you should just make sure that you completely understand if you haven't thought about them in a while. Radio navigation. Most of the time we're using the GPS, so it's in decline as satellite navigation becomes more prominent. But it's we're still using localizers and VORs for approaches sometimes. And if there's ever a problem with the GPS, you should have in mind what nav aids are out there that you can use to get to where you want to go. I think I used a VOR once down south to get back to San Juan, but it was there for me. And a lot of times I'll have nearby VORs tuned in with the bearing pointer, just in case there was some sort of emergency and engine failure. All I'd have to do is follow the arrow. So there's a whole lot less thinking involved when you have something going on like that. Also, for international ops, you might end up using NDVs or relying more on radio nav aids. And of course, the radio-based instrument approaches: VOR, ILS, localizer, and back course. So we'll start with VORs. It stands for Very High Frequency Omnidirectional Radio Range. I left out radio there. Frequency is 1080 to 117 905. The beginning of that spectrum is actually used for ILS. And VOR radios and courses are all magnetic. Just remember that. And almost all are Vortex, not standalone VORs that include DME. VOR service volumes are included there. The service volumes are for off-route navigation, so if you are on an airway that goes beyond these service volumes, just remember that if the airway is published, that's okay. These are published, these service volumes are published for when you're flying VOR to VOR. And you can find in the EFD the type of VOR. VORs continued. They define our Victor Airways and jet routes. These were defined in a previous presentation. In trade wind aircraft, we can use the VORs to navigate using OBS, the HSI, or the bearing pointer. We have all three, as far as I know, in all the trade wind aircraft. Full scale deflection when you're navigating off a VOR is 10 to 12 degrees off course. Morse code every 10 seconds. In the Garmin's, when you see that ID come up after you tune the frequency, that is not saved in the database. That's actually, the GPS reads the Morse code, so you can count that as ID'd. You don't necessarily have to listen to the nav aid if you have that. DME is the same, but every 30 seconds it's a higher frequency sound, so that's how you distinguish between the VOR and the DME Morse code. OTS, that's what is transmitted via Morse code if it's out of service. And of course we can listen to HIWAS over the VORs. To shoot a VOR approach, you must use the VOR as with the other types of radio approaches. If it's in the GPS database and you have it loaded, you can fly up to the final approach fix using the GPS, but technically to be legal you have to switch to primary nav source past the final approach fix. And also, if you're going to navigate a portion of the approach using GPS, you need to have the approach in the database. You can't just enter all the separate points. You can't enter the initial approach fix, some intermediate fix, and the final approach fix separately. It has to actually be in the database according to the FAA. However, you can, if it's not, for example, 688 or 668 doesn't have, it only has RNAV approaches in the GPS. You could enter one in there to use as a reference, but you'd have some backup to identify as well.
So what do you mean by must use the VOR? Are you saying that VLOC?
Like when you hit the final approach fix, you have to be using the VOR to navigate.
Right.
Rather than, you could just as easily leave it in GPS mode if you had it in the database.
Okay, so VLOC mode is acceptable.
Yeah.
I don't have to come off the GPS to a VOR radio.
No, just your nav mode has to.
That's what VLOC is, right?
Right,
That
so
pipes it to the,
Well, when you must use VOR,
Oh yeah, I meant the nav mode, yeah.
Okay.
DME required above flight level 240. If you have an IFR certified GPS with a current database, that can substitute for DME. For en route operations, a expired database is legal for en route as long as you verify all of the waypoints along your route. But that's only for en route. For approaches, you have to have a current database. DME is only accurate up to 199 miles from the station, and it's only accurate also, or the ground speed's only accurate when you're flying directly to the station. Just remember that, because you'll still get a ground speed readout if you are not flying directly to the station. And also, I didn't know this, but if there are too many aircraft on the station at once, the distance can become inaccurate. So I guess I'm not really sure of a good way to determine whether or not that's occurring, and without just comparing it to the GPS. Localizer glide slope. Localizer and glide slope are paired to form the ILS. The glide slope actually has a separate frequency, and in the radio, it's paired. They're all paired with a specific ILS frequency. Glide slope is usable from 18 nautical miles from the antenna site, where the localizer is. It's 4 times more sensitive than the VOR, so it's 2.5 to 3 degrees for full deflection from the center line of the localizer. And it's an angular width of 3 to 6 degrees to provide a linear width of 700 feet at the runway threshold. So the localizer is getting narrower as you approach the runway to be 700 feet at the threshold, and therefore more sensitive. Here's a diagram of the localizer within 10 miles. You might pick up readings within 35 degrees of the center line. From 10 to 18 miles, it's 10 degrees. A lot of times you'll see NOTAMs that say, localizer usable some other degree distance from the center line. Glide slope usable up to 10 nautical miles. It's normally a 3-degree descent angle. There is a false glide slope around 6 degrees, and there's actually another one at 9 degrees. And so it's important to pay attention to your descent rate if somehow you erroneously picked up a false glide slope. Along the final approach on a localizer, the outer marker is at the final approach fix. The middle marker is decision altitude, and if there's an inner marker, that would actually be for Cat 2 and 3 approaches. So we don't use the inner marker. And of course, if you're flying a back course approach, you can turn the HSI backwards to avoid reverse sensing, so it'll appear as normal like it would on a front course approach. NDB, non-directional radio beacon. There are the frequencies. We don't use NDBs very often. An interesting thing I learned is that NDBs are not line of sight like VORs. And you're on an NDB approach, you're supposed to use the primary nav aid, which would be the NDB, but it actually might be a little safer if you use the GPS in bearing mode to fly the approach. When an NDB is paired with a outer marker or middle marker, it's known as a locator outer marker. Usually they have a lower range, 15 miles. And on our aircraft, there are a few different modes on the NDB. On the ADF, use ADF mode, not the other modes. There's ANT and BFO. I forget what those stand for, but ADF is the correct mode. And on the GPS, currently 31 satellites with 2 spares in the constellation. We should have 6 or more in view at all times. To determine your position, the aircraft needs to have 4 in view, 5 for RAIM, and 6 for RAIM and fault detection. RAIM stands for Receiver Autonomous Integrity Monitoring. That's the GPS's ability to basically test itself for accuracy. And when it, I think I actually, RAIM, there it is. Detects faults. If you get a integrity flag like that on one of the Garmins, it means you have lost RAIM. If that happens inside of the final approach fix, you should abandon the approach. You can either climb or just stay level until you get to the final approach fix and then go missed. You can, all the GPSs have the ability to check for RAIM at your destination, at your estimated time of arrival. And you can also go online. RAIMprediction.net actually has a RAIM map for the whole U.S. as well as WAS service, and so you can look at a large map and see where you might run into problems and what time you might run into problems online. There's a picture of it. Actually, on the left there's a 530, the page where you would compute RAIM. So you can choose your destination, time, and push compute RAIM, and it'll tell you whether or not. And there's a picture of the website. So in this one, the red area for the time period specified, RAIM is unavailable there on that map. There's 2 types of IFR certified GPS systems. 668 has a TSO 129 non-WAS GPS. The Caravans, they don't have WAS either. And the rules are a little different for the TSO 129 GPSs. You have to check RAIM status before the flight. The aircraft has to have an alternate means of navigation on board, including your route for that day. So if you are flying A to B, you have to be equipped with an alternate means of navigation, and there has to be a backup plan. And you also have to have enough fuel to execute that backup plan. So if you're going IFR somewhere, you have to actually plan your fuel for the longer of the routes if your backup plan were to take a little longer and have sufficient fuel to land with the required reserves using that route. And also when you're planning alternates, the aircraft has to be able to fly an approach at the alternate without a GPS. So no GPS at all, you have to be able to get into your alternate using some other form of navigation. The other type, TSO 145 and 146, those are WASP GPSs. They can be used as primary navs. You do not have to have any other kind of navigation on board if you don't want it. And you can use a RNAV approach at the alternate. You would use LNAV minimums for that, however, not LPV if it was available. And IFR certified GPSs are all panel mounted. RNP required navigation performance. This is the accuracy as you get closer to your destination increases for en route. RNP used to be 5, now it's 2 miles. Within, I believe, 95% of the time, you have to be guaranteed to be within 2 miles of your course for en route. Terminal, that's within 30 miles of your destination. It will step down to 1 nautical mile. And then for approach, it will be 0.3 nautical miles either side of course. And approach mode, when you shoot an IFR approach, also has to be active. So you have to verify that the approach is active, approach mode is active in the GPS when you're flying an RNAV approach. Database is updated every 28 days. Maintenance does that. And if you are to use any kind of procedure, not just a instrument approach, but a sit or start, it has to be flown using the database. You can't enter the waypoints separately. And for example, if GPS isn't included in the name of the approach, then it can't be used for navigation between the final approach fix and missed approach point. I mentioned that earlier. What they used to do in the past, you probably saw, years ago, say VFR or GPS, localizer or GPS, something like that, and they're doing away with those. There aren't many of those left, but a lot of times you'll still see the NDB or GPS approaches out there, which allow you to use the GPS as well. In addition to the Victor Airways and jet routes, we have the T and Q routes now, which are the RNAV Airways. The dimensions are the same as the Victor and Jet Airways. They're just defined and specified for RNAV navigation, area navigation. This is WASP. This is the definition from the Garmin website. WASP consists of approximately 25 ground reference stations positioned across the United States that monitor GPS satellite data. 2 master stations located on either coast collect data from the reference stations and create a GPS correction message. This correction accounts for GPS satellite orbit and clock drift, plus signal delays caused by the atmosphere and ionosphere. The corrected differential message is then broadcast through 1 or 2 geostationary satellites or satellites with a fixed position over the equator. Information is compatible with the basic GPS signal structure, which means any WASP-enabled GPS receiver can read the signal. So basically, WASP uses stationary ground-based and space-based satellites to correct your signal and make it more accurate. Higher accuracy, more alternates, and lower minimums. So LPV versus LNAV. If we have WASP, we're flying LPV approaches, which has a glide slope. LPV stands for localizer performance with vertical guidance. It's not a precision approach, it's an approach with vertical guidance. And LPV approaches have decision height. I think that was mentioned before. However, in the Garmin's, you might get LNAV, VNAV, or LNAV plus V. Those also have a glide slope. However, it's just advisory. It's just descending you to the MDA, so you'll get there at the misapproach point.
So, just say the LPV is a non-precision approach?
Well, it's considered a non-precision approach. It's an APV approach.
So when do we have to disconnect the autopilot in the NGs? If you're doing an LPV approach in 111,
400 feet?
is it 400?
I think it's 400 feet. Non-precision approaches.
What about in the legacy airplanes with the WAPs? So I'm not that good. I usually
I
just
think
let
it's
the
like
autopilot
1,000
do
or
everything.
something like that. What's that?
I'm not that good at flying. I usually just let the autopilot do everything, so I'll wait till the last minute.
Typically, if you're flying the LPV approach like into Oxford, it's because it's too low for the ILS. So you're using a non-precision approach. to
Well, yeah,
get-
I'm saying,
to
like, because
get
in the
in when
legacy
weather's too
airplanes, the
bad for the
non-precision, you
ILS.
have to disengage the autopilot at 1,000 feet.
And then you'd have to hand fly it to 250 feet above the ground. Here.
It's funny though, sometimes that disconnect button doesn't work. 200 feet?
Weird.
It's funny.
It's a delay.
180 something. I didn't say that.
That's the end. Any questions?